Okay guys, so today we're going to learn about minerals. We kind of finished talking about the rock cycle and the three different types of rocks, and then we went into how to calculate density. So we are going to take some physical properties and talk about minerals and the way that we can identify them by their physical properties. So rocks are made up of minerals. A mineral is defined as a naturally formed solid that has a repeating three-dimensional structure. So all rocks, sedimentary, igneous, metamorphic, are all made up of minerals. So there is a difference between a rock and a mineral, and make sure you definitely write the definition of mineral. Some different types are called silicates, which obviously means that they have a lot of the element silicon in them. And here's some pictures of them. And then there's non-Nonsilictes. So one of the main ways that you can identify a mineral is by its physical property of color. Minerals can come in many different colors and shades. Small amount of impurities can change a mineral's color. Air and water can change the color of it. And for this reason, color is not the best way to identify a mineral. Because we know that, like, think of a penny, for example. If a penny is exposed to water or air, it'll turn green, which is not the same color as copper. So even though color is a way that we are used to identify it, it is not the best way. Luster, we had this vocabulary word when we were talking about metals and nonmetals. Luster is the way the surface of the mineral reflects light. This is another one of the physical properties that we will be using to identify minerals. There are three different types of luster. Metallic, which means shiny. Submetallic, which means somewhat shiny, kind of pearly or glossy. And non-metallic, which will be dull. So definitely know that luster is also a physical property. So color and luster are the two we have so far. Now, if you look at my picture, obviously, you can see that the one to the left has a luster. It is metallic. The one to the top right would be considered submetallic. And then the bottom one that's a crystal is obviously non-metallic. So streak. The definition of streak is the color of a mineral in a powdered form. When a mineral has been rubbed against a hard plate, which we call a streak plate, the mark that is left behind is called the streak. The streak color will not always be the same color as a mineral because, like I said before, air and water can affect the color, but it will not affect the streak. This is why the streak test is a much more reliable test than the color. So to determine the streak, you'll just take a streak plate, which is like a ceramic plate. You'll take the mineral and you'll scratch it across, and the color of the powder that is left behind is considered the streak. Let's talk about cleavage and fracture. Cleavage is a tendency of some minerals to break along flat surfaces. An example would be mica breaks into sheets, while halite breaks at a 90-degree angle. So these are the different types of cleavage. So cleavage is a way for a mineral to break along a flat surface. So 180 like a sheet or 90-degree angle. Fracture is a tendency for some minerals to break along a curved or an irregular surface. So if they do not have cleavage, then they tend to have fracture. So fracture is where it's irregular or curved. Cleavage is when it is at flat angles. So far, the properties we have are color, luster, streak, and cleavage and fracture will go into one. So those are the four properties we have been talking about so far. And the fifth one is hardness. Hardness is the mineral's resistance to being scratched. So when we talk about the hardness of a mineral, we have to talk about the Mohs hardness scale. It is a scale that scientists use to compare the hardness of minerals. So talc is a mineral that has a rating of 1 because it is extremely soft and easily scratched. Diamonds have a rating of 10 on the Mohs hardness scale because they are very hard. Now, you've probably heard that a diamond is the hardest material on Earth. Nothing can scratch a diamond because a diamond is on a 10 on the Mohs hardness scale. All other minerals are going to have a hardness between these two extremes. So Mohs hardness scale is going to go from 1 to 10, 1 being the easily scratched and 10 being the hardest to scratch, or almost impossible to scratch. Okay, so here's a picture of the Mohs hardness scale. I want you to pause the video and copy this down because this is going to become very handy when we are using this to identify some minerals. So notice from 1 to 5, we consider to be soft minerals, okay? And we have the name of some minerals over here. So 1, talc. Talc has a hardness of 1. Now, and gypsum, which is another mineral, has a hardness of 2. Now, your fingernail has a hardness of 2.5. So let me explain to you how you would do this. If you could take your fingernail and scratch it across a mineral, that means your fingernail is obviously harder if it's doing the scratching. So therefore, the mineral must either be a 2 or a 1, meaning it's either gypsum or talc. If you take your fingernail and rub it across the mineral and it does not leave a scratch, then that means the mineral has a hardness higher than 2.5, so it must be 3 or above. So then you need to find another instrument to try to scratch it to determine its hardness. Okay, so a penny or a copper wire has a hardness of 3.5. Calcite has a hardness of 3. So if it doesn't get scratched by your fingernail, but it does get scratched by a penny, that means it has to be in between 2.5 and 3.5, which is 3, which would mean it is calcite. Taking an iron nail, that has a hardness of 4.5, so if it does not get scratched by a penny, but it does get scratched by an iron nail, that must mean its hardness is 4, so it would be fluorite. Taking a knife blade or a filing board or even a piece of glass, that all has a hardness scale of 5.5. Now, many people would tell you, you can always tell the difference between a real diamond and a glass diamond by if it scratches glass. Well, if you take a diamond, do you think it's going to scratch the glass? Well, of course it is, because a diamond has a hardness of 10, where glass has a hardness of 5.5. But what if it gets scratched by the glass? Then obviously it's not a real diamond, and it could be what we know as a cubic zirconian. Orthoclase feldspar has a hardness of 6. Now, the streak plate that I talked about that we use to determine the streak, which is another physical property, it can also be a tool to use to measure the hardness scale, which is a 6.5. So if you go through your fingernail, a penny, a nail, a memory board, or streak plate, and none of them scratch it, then that must mean it is obviously higher than a 6.5, so it could be a 7, 8, 9, or 10. Okay, so 6 through 10 is what we consider to be a very hard mineral, which could be quartz, topaz, corundum, or diamond. Okay, so again, make sure that you copy this down. All right, density, which is what we just got finished going over, is a measure of how much matter there is in a given amount of space. And then some elements have special properties. Some properties are particular to only a few metals. Like some can actually have a certain taste. They could taste salty. Some can actually glow under a black light because they're fluorescent. Some might be magnetic. There are many other special properties that some minerals can have. All right, so that's where we're going to leave off. So make sure you have the 6 main properties that we will be using to identify minerals. And again, if you need to go back or pause the video and rewrite them, and make sure you have all the definitions. Okay, I'll check your notes in just a bit.